Alrighty guys, so this question is pretty straightforward, and but there are actually two ways of solving for energy stored inside of a capacitor. The equations that I'm just talking about is 1 half QV or 1 half CV squared. And these are actually the same equation, just with some substitution going on, because if we think back to our capacitance equation, capacitance is charge over volts, and if you were to isolate just for charge, then you would get that charge is equal to capacitance times voltage, and then substituting that into this equation here, you would end up with this equation, because you would be putting in capacitance, and volts times another volts would be volts squared. So that's how you end up with that equation out of this equation, demonstrating that they really are the same equation. It's just that if you don't have, for example, if you don't have charge, such as in this case, then we would use capacitance instead. And so we're going to go ahead and just plug and chug at this point. We're going to do some conversions so we don't end up with some really funky numbers. Since this is in volts, I find it easier to just convert microfarads to farads. And so we'll do 1 half times 0.0015 farads times 25 volts squared. And don't forget to square that. It's a very important and very easy mistake that we could make. And then when you solve for that, you get 0.047 joules. And then since the answer is desired in millijoules, we would just move that over 3 spaces and we get 47 millijoules.